Hello students, welcome to Boundless Maths, your trusted space for both maths and science. In today's video, we are going to cover the chapter Metals and Non-Metals from Class 10 CBSE Science curriculum. Now, in order to score well in any exam, you need to follow a three-step process. Number 1, understand the content. Number 2, learn the content without missing important details using structured notes. And number 3, practice as many questions as you can as per the pattern of the paper you are going to appear for. So without much delay, let's get started with metals and non-metals, where I am going to cover the entire content using the Class 10 Science notes authored by me, specifically designed to make the NCERT content concise, easy to learn and remember. It is like a companion for your NCERT textbook. So if you want a copy of these notes, visit my website www.boundlessmaths.com. So let's start with what are metals and what are non-metals. As we all understand, metals are the elements that are present towards the left of the periodic table, left few columns of the periodic table. These elements form electropositive ions by losing electrons. And non-metals are the elements present on the right side of the periodic table. These elements form electronegative elements by gaining electrons. So let's look at some of the physical properties of metals and non-metals. Number 1, existence. Metals exist as solids at room temperature, except mercury, that is the only liquid metal. Non-metals exist either in solid or gaseous state, except bromine, which is a liquid non-metal. Now in this entire table, the exceptions are highlighted, and these exceptions are very important from examination perspective. Second property is luster. Luster means shine. Metals are lustrous, whereas non-metals are not lustrous, except bromine and graphite, which are lustrous non-metals. Next is hardness. Metals are generally hard. As they are solids at room temperature, they are generally hard, except sodium, potassium and lithium. They are so soft that they can even be cut with a knife. Now non-metals, they are not hard, except diamond, which is the hardest natural substance known, which has a very high melting and boiling point. Malleability. It is the property by which any substance can be beaten into thin sheets. So you must have seen silver foil on sweets that you order from the sweet shop. It's a very thin silver foil that is there on the sweets. And we have also used aluminum foil in the kitchen. So that is also used, some people use it. So that foil is also so thin. It is used for wrapping food. So all these are made from malleable metals. So gold and silver are the most malleable metals, whereas non-metals are not malleable. Next property is ductility. It is the ability of a metal to be drawn into thin wires. Now we have all the gold jewelry made of gold. Why? Because gold is the most ductile metal. Metals are generally ductile. Gold is the most ductile. Just 1 gram of gold can be drawn into 2 kilometer long wire. So just remember this fact. It is given in your NCERT book, very important from MCQ perspective. Non-metals are not ductile. So don't get confused between malleability and ductility. Malleability is ability to be beaten into thin sheets, and ductile means wires. Next, conductivity. Metals are good conductors of heat and electricity, and the best conductors are silver and copper. Now because copper is available abundantly and can be extracted easily, so that's why we have electric wires made of copper and not silver, otherwise they would be very expensive. Now lead and mercury, they are poor conductors. So these are exceptions. Please remember all the exceptions. Electrical wires, they have a coating of PVC. Full form of PVC is polyvinyl chloride, or a rubber-like material to prevent leakage of current. So both these things are very important. Best conductors amongst metals are silver and copper, and poor conductors are lead and mercury. Now when we come to non-metals, non-metals are generally poor conductors of heat and electricity, except graphite. Graphite is a good conductor of electricity. Melting points. Metal normally have high melting points, except gallium and cesium. Again, very important, gallium and cesium are the two metals that melt even on your palm. Non-metals, they generally have low melting point. And the last property is sonorous. So the metals, they produce sound on striking a hard surface. For example, if you go to the temple, when you strike that bell, you can see that hear that sonorous sound. So that is being sonorous. So metals are sonorous, whereas non-metals are not. So that is it about all the physical properties of metals and non-metals. It is very important that you learn the exceptions for both these categories. Now let's have a look at the chemical properties. Before getting into the details of chemical properties, I hope everyone understands and remembers the reactivity series already done in grade 9. Pause this video and speak up the reactivity series. Sodium, potassium, yes? Do you remember the entire reactivity series? Let's see how to learn the reactivity series or how to just recall the reactivity series before we get into the details of chemical properties. So, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, and after hydrogen we have copper, silver and gold. How to learn that? Please stop calling me a zebra, instead try learning how copper saves gold. So, this helps you with the initials of these metals that have been arranged in the reactivity series. Now, if you remember this reactivity series, it is very easy to relate all the chemical properties of metals because they are all graded in the form of this reactivity series only. So, let's go back to the first property. The first property is burning in air. So, when we talk of burning in air, the first two metals, sodium and potassium, they react vigorously when even kept open. If you keep them exposed to air, they will even catch fire. If you keep them under water, they react with water. So, they are highly reactive metals, so it is very difficult to store sodium and potassium. So, they are generally stored in kerosene because kerosene is an oil, it cuts off the supply of air and water and keeps them safe. So, sodium and potassium, they react vigorously when kept open. Next, we have magnesium. The first activity of this book from the first chapter, burning of magnesium ribbon. It burns with a white dazzling flame, leaving white ash of magnesium oxide. And you rub the magnesium ribbon with the sandpaper before you try to burn it. So, why do we do that? Because magnesium is a highly reactive metal. It gets covered with a layer of oxide, magnesium oxide, because of oxygen present in the air. So, you rub it with sandpaper to remove the layer of magnesium oxide so that it can burn smoothly. So, magnesium, aluminium, zinc and lead, all these get covered with a thin layer of oxide. Visibly it is not there, you can't see that oxide layer, but they need to be rubbed with the sandpaper before you try to burn any of them. Now, one of the reactions given in your textbook is for aluminium. Aluminium plus oxygen gives Al2O3. So, that is the metals, when they are burnt in air, they form their corresponding oxides. Next metal is iron. Iron does not burn on heating as such. If you take an iron log and try to burn it, it may not burn. But iron filings, because they have higher increased surface area, they burn vigorously when sprinkled on a flame. Done. So, we have covered sodium, potassium, magnesium and then iron. Next, copper when heated in air changes to black oxide. You need to remember this black color of this copper oxide. The reaction is Cu plus O2 gives CuO, copper oxide. This is black in color. Silver and gold do not react with oxygen even at high temperature. Now, there are certain oxides that show both acidic and basic behavior. Such oxides are called amphoteric oxides. So, you need to remember this word ZALT, salt. Zinc, aluminium, lead and tin are the four oxides that are both acidic and basic in nature. They react with even with HCl and they also react with NaOH, forming their corresponding salts. So, for example, Al2O3 reacts with HCl to form AlCl3 and water, and it also reacts with the base, that is NaOH, to form NaAlO2 plus water. So, there are certain amphoteric oxides that react with both acids and bases. Again, to learn it, remember the word salt, zinc, aluminium, lead and tin. Easy? So, let us do a quick walkthrough of these properties of metals for burning in air with respect to the reactivity series in mind. In the top we have sodium, potassium, so they burn vigorously. Next we have magnesium, it burns with a white dazzling flame. Next we have iron, iron does not burn as such, but iron filings, they do catch fire when sprinkled on a flame. Next is copper, copper gets converted to copper oxide when heated in air. And then we have silver and gold that do not react with oxygen even at high temperature. Now, before we move to the next property, there is a keyword given in your textbook that is called anodizing. What is anodizing? There are lots of articles or maybe small showpieces or statues of gods and goddesses made of aluminium. Right now, these might react with oxygen present in the air and get corroded over a period of time. So to prevent this, these are anodized. What do we mean by anodized? They are connected to the anode and they are electrolyzed with dilute sulfuric acid. Now when they are electrolyzed, oxygen gas is evolved at the anode and it reacts with the aluminum article. So aluminium plus oxygen becomes aluminium oxide. So it reacts with the aluminium article oxygen gas that is being released at the anode and it makes a thick protective oxide layer on that article. Now this thick aluminium oxide layer is very even and it prevents the article or that object from getting corroded in future. So this oxide layer can even be dyed to give them attractive finish to the aluminum article that has been connected to the anode. So you need to understand what is anodizing. The second property of metals is solubility in water. Now when we talk about solubility in water, all metals they form their corresponding oxides, and the highly reactive metals that are very reactive, their oxides get converted to hydroxides. So for them oxide is just an intermediate product and they get converted to metal hydroxides. Now most of the metal oxides they are insoluble in water. But there are certain oxides that are soluble in water, they are called alkalis. For example, sodium and potassium oxide, they dissolve in water to form sodium hydroxide and potassium hydroxide. So these are called alkalis. So now let's look at the properties of these metals with respect to the reactivity series in your mind. The first two metals, again sodium and potassium, they react vigorously even with cold water. It is an extremely exothermic reaction. The H2 gas that is evolved may even catch fire. So if you look at the generic statement, metals plus water, they form metal oxides and hydrogen gas is released. So this hydrogen gas even catches fire because this is a highly exothermic reaction. So these three metals, sodium, potassium and even calcium, they react with water even at room temperature. So that's why their intermediate oxides, they get converted to hydroxides. So for these three metals, you will have hydroxide in the reaction, not oxide, because they are highly reactive. These oxides get converted to hydroxides. For example, the first reaction of potassium plus water gives potassium hydroxide, KOH. Sodium plus water gives sodium hydroxide. Heat is evolved along with the liberation of hydrogen gas. Right? Now calcium. Let's come to calcium. Reaction of calcium with water is less violent as compared to sodium and potassium. So this evolved H2 does not catch fire. In case of sodium, potassium, it may catch fire, but not in case of calcium. So calcium starts floating. You need to remember this property. Calcium starts floating as the bubbles of hydrogen gas stick to the surface of the metal. So you can see calcium floating in the form of froth with hydrogen gas captured in the bubbles of hydrogen gas. So calcium plus water gives calcium hydroxide and H2 is released. Magnesium does not react with cold water. Now till here, sodium, potassium, calcium, they were reacting with cold water even at room temperature, but magnesium does not react with cold water. Now you need to heat that water. So it reacts with hot water and it also starts floating due to the bubbles of hydrogen gas sticking to its surface, right? So both these metals, they start floating because of the formation of bubbles of hydrogen gas. However, magnesium reacts with hot water, calcium reacts with cold water. Magnesium, when reacted with hot water, it forms magnesium hydroxide, whereas when it reacts with steam, so you can see the states here. This is liquid, water is liquid here and water is in the gaseous state here. So when magnesium reacts with steam, it forms magnesium oxide. Fine. So both the reactions are important because magnesium forms hydroxide with liquid water and it forms magnesium oxide with steam. Next, aluminium, iron and zinc. They do not react with hot or cold water. Now you have to heat it even further, but they react with steam to form metal oxides and hydrogen gas. So if you look at aluminium, iron and zinc, all these three metals, they react with steam. So it is in the gaseous state. Water in the gaseous state and they form their corresponding oxides and hydrogen is released. Metals like lead, copper, silver and gold do not react with that metal at all. So are you able to relate it to the reactivity series again? Sodium, potassium, they react vigorously, even catch fire with water. Calcium, it is less violent, it does not catch fire, but calcium starts floating on the surface because of the formation of bubbles of hydrogen gas. Magnesium does not react with cold water, it reacts with hot water. So magnesium onwards, the water needs to be heated. So it reacts with hot water, it forms hydroxide with liquid water and oxide with steam. Aluminium, iron and zinc, they react with steam to form their oxides and hydrogen is released. And lead, copper, silver, gold, they do not react with water at all. So this was the property of reactivity with water for all the metals in the reactivity series. Now let's come to reaction with acids. Metals react with acids to form salt and water. So there are two categories of acids. The first is non-oxidizing acids, that is HCl and dilute H2SO4, and the oxidizing acids that are concentrated H2SO4 and HNO3. Why they are called oxidizing acids? Because they are highly oxidizing in nature. Normally we have hydrogen gas being released with an acid, but what happens with concentrated HNO3 and concentrated H2SO4? Because they are oxidizing acids, they do not let hydrogen be released, they oxidize it to make water, and they also release nitrogen oxides, N2O, NO or NO2, any of these. So let's look at the reactivity of all these metals again. Magnesium, aluminium and iron, they all react with acids forming their salts and hydrogen is released. Again, hydrogen is released with non-oxidizing acids but not with oxidizing acids. Bubbles of hydrogen gas can be seen with all these metals but not with copper, as copper does not react with dilute HCl. Hydrogen gas is not evolved when a metal reacts with nitric acid. This is very important. When metals react with HNO3, hydrogen gas is not released because HNO3 is a strong oxidizing agent and it oxidizes hydrogen to produce water, and itself it gets reduced to any of this nitrogen oxides, that is N2O, NO or NO2. So if you write the reaction of zinc with HNO3, you will get the salt ZnNO3 twice, but there is no hydrogen, you instead have water and N2O. Please learn this reaction, it is very important, zinc plus HNO3. Next is, these are exceptions again, magnesium and manganese, they react with very dilute HNO3. As you can see, dilute HNO3, again HNO3 is because it is an oxidizing acid, but with magnesium and manganese, these are exceptions. They react with dilute HNO3 to evolve hydrogen gas. So the reaction here is magnesium plus HNO3 gives MgNO3 twice plus hydrogen. So only with magnesium and manganese, hydrogen gas is released when you are using HNO3, but with other acids, other metals, they release hydrogen gas. Clear? Now this entire chemical properties, all the three categories have been captured here in the form of just one table on one page of these notes. So as you can see, let's do a quick recap of all the chemical properties. If you have these notes, take a printout of this page, put it on the pinboard in front of you, put it on the cupboard, put it on the door, wherever you feel like, for a quick recap of the entire chemical properties of metals anytime, whenever you want. So let's start with the recap of all the chemical properties that we have just discussed. The first one, if you look at sodium and potassium, they are highly reactive metals. So sodium, potassium, they react vigorously when kept open. Sodium, potassium react with cold water, highly exothermic reaction, H2 gas is evolved. The reactions are here, they form their hydroxides. Calcium starts floating, again it also forms hydroxides, whereas other metals, they form oxides. Reactivity with acids, sodium, potassium, calcium, all these react to form their salts and hydrogen is released. Let's look at magnesium. Magnesium burns with a white dazzling flame. Magnesium, aluminium, zinc and lead, they get covered with a thin layer of oxide when exposed to air. Now they do react with cold water. Magnesium does not react with cold water, it reacts with hot water, because sodium, potassium, calcium, they reacted even with cold water at room temperature also, but magnesium needs the water to be heated, so it reacts with hot water to form magnesium oxide, and it reacts with acids to release hydrogen gas and MgCl2 is formed. It reacts with HNO3, now this was the exception. Magnesium plus HNO3 gives you H2 but not H2O and NO2 or N2O. So it is MgNO3 twice plus H2, this is an exception, so it is a very important reaction, please learn that. Magnesium plus HNO3 gives MgNO3 twice plus hydrogen gas is released here, even though with HNO3 other metals do not release hydrogen gas. Next is aluminium. Aluminium burns with a white flame again, it gets covered with a thin oxide layer. Anodizing is the process of forming a thick layer of aluminum oxide. Amphoteric, other amphoteric oxides are ZALT, zinc, aluminium, lead and tin. So here you are given the reactions of aluminium with HCl as well as NaOH to show both acidic and basic behavior. Now aluminium does not react with cold or hot water, but it reacts with steam to form metal oxide and hydrogen is released. Again, zinc does not react with cold or hot water, but it reacts with steam. So both these, they react with steam and form their oxides and hydrogen gas is released. Aluminium reacts with HCl, again H2 is released. It does not react with dilute HCl due to its protective oxide layer. So you need to have concentrated HCl. Zinc reacts with HCl and H2SO4 and it forms hydrogen, whereas with HNO3 it does not release hydrogen now, it releases N2O and H2 gets oxidized to H2O. So H2 is not released here with HNO3 because HNO3 is a very strong oxidizing agent. Next, iron. Iron does not burn on heating, but iron filings when sprinkled on flame they catch fire. Iron reacts with steam. So iron plus water gives Fe3O4 plus H2 and iron reacts with HCl liberating H2 gas. It reacts with dilute H2SO4 also. Next, lead and copper, if you look at them, they also get converted to their oxides on reacting with air. They do not react with water at all. So below copper we have gold and silver. They do not react with air, and for water from lead onwards they do not react with water. Next, it reacts with HCl and dilute H2SO4 and again H2 gas is evolved with lead but not with copper. Copper H2 gas is not evolved with nitric acid HNO3 because it is again a strong oxidizing agent. So only in case of magnesium you can see H2 getting involved with HNO3, but others they don't release hydrogen with HNO3, they release hydrogen with other acids HCl and H2SO4. So this is the entire summary of the chemical properties of metals. Now let's look at the reaction of these solutions, metal solutions of other salts. Again repeating the reactivity series, pause this video, just do a recap of the reactivity series in your mind. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, tin, lead, copper, silver, gold, and there is hydrogen before copper. So the reactivity series tells you that a higher reactive metal can displace a lower reactive metal from its salt solution, but not the opposite. So metal A, salt solution of metal B, which is lesser reactive than A, then you get the salt solution of A and metal B is displaced. So this is displacement reaction, we have covered this in chapter 1 also. So you need to learn this reactivity series in order to write the correct displacement reaction. Next is, what is aqua regia? It is a mixture of concentrated HCl and concentrated HNO3 in the ratio 3:1. Now don't write it opposite. The sequence or the order is very important here. Concentrated HCl and concentrated HNO3 in the ratio 3:1. It is a highly corrosive and fuming liquid that can even dissolve gold and platinum. So gold and platinum are the least reactive metals, but this mixture of HCl and HNO3 is highly corrosive and highly reactive, so it even dissolves gold and platinum. Now this is the basic reduced form of the periodic table. I hope everyone understands and knows the first 20 elements of the periodic tables along with their atomic number. This has all been covered in grade 9. So if you don't remember how to learn it, HHeLiBeBCNOFNeNaMgAlSiPSClArKCa. So just speak after me again. HHeLiBeBCNOFNeNaMgAlSiPSClArKCa. Why do we need to learn them in this order? Because they are arranged in the form of increasing atomic number, and if you know them in the sequence, how they are placed in which column of the periodic table, what is their symbol, what is their electronic configuration, what is their valency, how and what kind of ions do they form, then it is very easier to understand how compounds get formed by exchange of electrons. Now if you have we have already seen that metals, they are called electropositive elements because they form positive ions by losing electrons, whereas non-metals are called electronegative elements because they form negative ions by gaining electrons. Now these positive and negative ions that get formed after losing or gaining electrons, they are like two poles of a magnet, north pole and south pole. They get attracted towards each other and they combine together to form compounds. For example, if we look at sodium, the atomic number for sodium is 11. So the electronic configuration is 2, 8 and 1. There is one electron in the outermost shell. Now sodium loses this extra electron and gets converted to Na plus ion. Chlorine in the 7th column of the periodic table with the electronic configuration as 287, it needs one electron to become stable. So this chlorine captures this electron and gets converted to Cl minus ion with the configuration as 288. Now this positive and negative ion, they get joined together by an electrostatic force of attraction and they form NaCl. So this is very important, the electron dot structure showing the transfer of electron from sodium to chlorine, that is formation of NaCl. This is very important from examination point of view. Next compound we have is magnesium chloride. Now magnesium is in the 2nd column of the periodic table, so it has a valency of 2 with 2 electrons in the outermost shell. So it loses the 2 electrons and becomes stable with electronic configuration 2,8. Chlorine, now because chlorine just needs 1 electron and magnesium is given out 2 electrons. So that means 2 chlorine atoms will gain 1 electron each and they get converted to MgCl2. So the basics we have already covered in grade 9. Here you need to understand how to draw this electron dot configuration. If you get a question on this, you need to write the atomic number, the valency, the electronic configuration of both the elements involved, then show the transfer of electrons using the arrows. Show the transfer of electrons, this is very important. And then write the formula also in the end. When you are talking about electron dot structure or how transfer of electron takes place, you have to write the formula also of the compound that gets formed. Clear? Wonderful. So now let's have a look at the properties of these ionic compounds. Now these compounds are called ionic compounds because they are formed by transfer of electrons, and these transfer of electrons creates ions of opposite charges that get attracted to form these compounds. The other name for ionic compounds is electrovalent compounds. So these compounds are also called electrovalent compounds. They are formed by transfer of electrons. So the first is physical properties. All these ionic compounds, they are hard solids because they have a strong force of attraction between the positive and the negative ion. However, these compounds are generally brittle and break into pieces when pressure is applied on them. Okay. Next is boiling and melting point. Now these compounds, they have high melting and boiling point because you need lots of energy to separate the two ions that are attracted towards each other and combine together. Solubility. Ionic compounds, because they are formed by ions held together by force of attraction. So when dissolved in water, they get disassociated into ions. Now they are generally soluble in water but insoluble in solvents like kerosene and petrol. So they are insoluble in these. Conduction of electricity. Now because these are made up of ions, in solid state they do not conduct electricity. However, in molten state or when dissolved in water, that means in the solution form. So only in molten state or in the solution form, the ions get separated out and they start moving freely to conduct electricity. But in solid state, they do not conduct electricity. So that's it, what we have about physical and chemical properties of metals and non-metals. In the next video, we are going to cover the extraction of metals from their ores. So if you like the video, if the video was useful, don't forget to click the like button. Share the videos with your friends, those who are struggling to learn the chemical properties of metals and non-metals. Subscribe to my channel if not done so far. Hit the bell notification icon to get notifications for upcoming videos. So keep watching, keep learning, keep growing. Till the next video, thank you so much.